Yes, Dipangi Bas. Good evening. Mm, Okay, let's go for 1 more minute. Okay, okay, cool. So let me share my screen. Now I have given my introduction previously, right? किसी को कुछ पूछना
Yes.
था? किसी को कुछ पूछना था? और कुछ सर क्या पढ़ाएंगे क्या नहीं ऐसा कुछ? ओके, my screen is visible. Hmm. Let me open a PPT. Guys, my screen is visible.
Yes.
Yes,
Hmm.
sir.
Now it's
Yes.
visible.
Hmm.
Yes, sir.
Yeah, your screen is visible.
Hmm. Okay. Okay. So, first, the projects are assigned to you or not?
No, sir.
Okay, it will be assigned. And when we are going for the project, when you are going for the projects, let me tell you that you can use data analysis and visualizations using Python. At the same time, you have to visualize the dashboards in Power BI. Okay. Any question?
No, sir.
So, introduction to data analytics. You all know what do you mean by data analytics actually? It is the process of examining data sets to uncover patterns, insights, and draw the conclusion. Means what? Data analytics is the process of examining, cleaning, transforming, and modeling the data to discover useful insights, support decision making, and identify the patterns. And it involves various techniques and tools to analyze the structured and unstructured data for better business intelligence and for better prediction. Yes?
Yes.
Yes.
So as you can see over here, what is enterprise analytics solution, data collection services, data quality, access and improve data integration, policy analytics, social media and digital outreach, all those stuff involves in data analytics because it involves various methods and processes to transform data into actionable insights. Understanding data analytics is essential for informed decision making in numerous fields. Organizations leverage data analytics to make informed decision drive their strategy. Now it comes to our discussion part, that what are the types of data analytics. Anyone knows? Anyone over here?
Yeah,
ऐसे
descriptive,
silent मत रहो,
predictive,
ठीक
and
है?
I guess two more are there.
हाँ, हाँ.
Descriptive is about describing the current scenario, and predictive is about predicting the future scenarios and trends, I guess.
Oh, okay. There is descriptive, prescriptive, predictive, then another one is diagnostic. Yes. What is descriptive? Because data analytics is broadly categorized into these four types. What is descriptive? We will discuss in detail. Means what happened. Descriptive means what actually happened. Okay. Means it involves and it focuses on summarizing the past data to understand the trends and pattern, and it provides insights into historical performance using various data aggregation and visualization techniques. Some of the techniques to perform descriptive analytics are data aggregation, data visualization, statistical measure. Data aggregation we are using for means the common examples are summing, averaging, like this, and some data visualization techniques like you are using for charts, graphs, dashboards, etc. 10. Statistical measures. What are the various statistical measures? You can tell me. Quick, quick, quick. Hmm. Am I audible?
Mean, mode, median.
Yes, mean, median, mode, standard deviation, all those stuff.
Correlation.
Okay,
Hypothesis
now,
testing.
Regression analysis.
okay, now if you come to the term of mean, median, mode, then tell me what is mean, what is median, what is mode, and what is standard deviation. Huh? Tell me.
Mean means we are taking the average of a set of numbers.
Mhm.
Median means taking up the middle value in a set of group of numbers. Mode
Mhm.
is we are taking the number which is appearing most oftenly in the given numbers.
Mhm. What's your name,
Mm,
buddy? Buddy, what's your name?
Vam- Vamsi.
What?
Vamsi.
Full name?
Sri Vamsi, sir.
Oh, अरे नंदूरी श्रीवंशी.
Yeah.
Okay, cool. Tell me then, what is standard deviation? What is mode? Okay, let me
Uh,
discuss. Okay,
mm,
these are the fundamental statistical measures like mean, median, mode. Mean means the average. Okay, mean means average means the sum of all values in a data set divided upon the total number of values. Means it represents the central tendency of the data. Okay, if we'll take the example, I will calculate the mean. If the data set are available 5, 7, 9, 10, 15, how the mean can be calculated? 5 plus 7 plus 9 plus 10 plus 15 divided upon total number of observations, that is 5, is equal to 920. What is median? Median means it is the middle value of a sorted data set. Means if the data set has even number of values, the median is the average of two middle numbers. Okay. What is mode? Mode is the number that appears most frequently in a data set. Means the data set can have one mode, two modes, one mode that is unimodal, then two modes having bimodal. Okay, and these are useful. These modes are useful for categorical data, means most popular product color, and these are not always represent the numerical data. Okay, and what is standard deviation? Standard deviation tells us how much the data varies from the mean. Means the higher the standard deviation indicates that the data points are most spread. Yes, got it?
Sir.
What is mean, median, mode? What are the comparison if we'll talk about? Then mean is the average of the values. Median is the middle value of the sorted data. Mode is the most frequently occurring value. Standard deviation is the spread of data around the mean. Okay, we are using mean for normal distribution, median for skewed distribution, mode for categorical and frequency of the data, standard deviation for variability analysis. Then uh, mean is affected by the outlier, but median, mode are not affected by the outlier, but standard deviation is affected by the outlier. Okay, means this mean, median, mode, standard deviation, these measures this help us to summarize and understand the data set. Mean and standard deviation are useful for normally distributed data, while median and mode are useful for skewed or categorical data. Clear? Hmm.
Yes, sir.
Yes, sir.
Thank you. So we are discussing what is descriptive. Descriptive means it is analyze means descriptive analytics focuses on summarizing the past data to understand the trends and patterns, and it provides insights into historical performances using various data aggregation and visualization techniques. Okay, there it comes some techniques like data aggregation, visualization, statistical measures comes to play. Okay. Then some common examples of descriptive analytics are monthly sales reports showing revenue trends, customer demography analysis, then traffic analysis, some of them. Yeah. Some diagnostic analytics. Then the second term is diagnostic. After descriptive, there is some diagnostic. Diagnostic means this analytics helps identify the reason behind the past outcome by uncovering the correlations and patterns in that, and it goes beyond descriptive analytics by analyzing the relationship between the variables. Okay, what are the key techniques used in diagnostic analytics? There's a technique called drill down analysis, correlation and caution analysis, root cause analysis, that is RCA, we are using for diagnostic analytics. Means some of the common examples are identifying the reasons for sudden drop in the sales, analyze the customer churn to find out common reason for leaving, then detecting causes of manufacturing, this stuff. Okay, the it is gone for diagnostic. Then the next term is predictive analytics. What is analytics? Predictive analytics uses a statistical model and machine learning technique to forecast the future trends based on the historical data. Future trends based on historical data, and it helps businesses to anticipate the outcomes and make proactive decisions. Got it?
Yes,
Yes,
sir.
sir. Yes, sir.
Some key techniques like your predictive regression analysis, means your linear regression, logistic regression, then time series forecasting, then some of the machine learning models like decision tree, neural network, like predictive analytics comes to play. So when it comes to regression analysis, linear regression, logistic regression, first understand what is machine learning. Anyone? कोई है क्या?
Machine learning is basically a technique where machine directly learn from the data present around itself to train itself.
To train itself. Okay.
A machine
Anyone?
learning is a technique in which we like train a machine for the particular purpose of it, like training a machine from the pre-recorded datas or pre-recorded inputs. Like we provide pre-recorded inputs and pre-recorded outputs according to the inputs to
Hi.
train a data, to
Can
train a
you,
machine. Sorry.
sir, can you please explain in simple language?
Okay, listen, I think we'll take 2 to 3 classes for machine learning algorithm analysis. But today, do you want to discuss machine learning after this?
Yes, sir.
Yes, all of you. I'm asking all of you. If you are interested, then I can leave to this talk. Then these are
Okay,
the
sir. Okay.
those are the part of data analytics, means data science, analytics, machine learning, artificial. These are correlated, right?
Yes, sir.
Yeah.
If you want to
Yes, sir.
discuss this properly, then I'm ready to discuss because I'm the means I want those topics to discuss. Okay, because I'm the trainer for means data science and analytics. So I think to revise my stops. Okay, frankly saying, while छुपाना कुछ नहीं है. Okay, so let me discuss this first. Then we can directly move to today machine learning. Will discuss. Okay, let's discuss. Fine. So first, okay, let me complete this. 4 types of analytics. Then we'll discuss the machine learning. Cool, guys. Am I audible?
Okay, sir.
Yes, sir.
Yes.
Yes, sir.
So then it comes to so in that when we'll discuss machine learning, first we'll discuss the data science. What is data science? What is all about all this stuff? Then we can go in a flow. Okay. Now come to the topic that is predictive analytics gone. Then the last one is prescriptive analytics. What is prescriptive analytics? It is provides the recommendation on the best courses of action based on the predictive insights, and it uses optimization algorithm and AI to what to suggest the decision making strategy. Okay, cool. Guys, am I audible?
Yes, sir. Yes.
Yes, sir.
Yes.
Yes.
माइंड कर रहे हो क्या कि सर अभी बोले नहीं, सर डिस्कस करेंगे कि नहीं, मतलब बुरा लगा क्या किसी को? बोल सकता है भाई.
Sir, can you go back and explain the prescriptive part?
Yeah, prescriptive. Prescriptive means it provides the recommendations for the best choices of action based on predictive insights, and it uses optimization algorithm and AI to suggest decision making strategy. Okay, now it comes to the term optimization. What is optimization in what is optimization? Tell me. कोई है? It is the
Basically,
process of
simplification of any process. We
Mhm.
can say optimization.
Optimize. Anyone?
Sir,
Optimization is the process of finding the best possible solution from a set of alternatives when it's given a set of constraints. When it is widely used in businesses, engineering, economics, machine learning to improve the efficiency and decision making. There are some types of optimization like linear optimization, then non-linear optimization, integer optimization, dynamic optimization, stochastic optimization. Should we discuss the types?
yes, sir.
Yeah, sure.
Yes.
So
Yes.
now
Yes,
first,
sir.
what is linear optimization? It is used for problems where the objective function and the constraints are linear. Means suppose a factory produces two products, that is A and B, using limited resources, and the goal is to maximize the profit while staying within resource constraints. Okay, means the techniques like your simplex method, graphical method we are using for linear optimization. What is non-linear? The second one, when either the objective function or the constraint are non-linear. Means common example, when you are what maximizing the revenue based on the non-linear price demand function, we are using non-linear optimization. Some common algorithms are gradient descent. What is gradient descent now comes into play? What is gradient descent? Anyone? ओ भाई तुम लोगों के लिए
No
नया
idea.
टर्म
No
है क्या
idea,
ये
sir.
सब? Okay. Gradient descent is an optimization algorithm that used to minimize a function by iteratively updating its parameter in the direction of steepest descent, that is negative gradient, and it is widely used in machine learning and deep learning for optimizing the cost function. How it works, gradient descent? It aims to find the minimum of a function, means typically loss function in machine learning, means first initialize the parameter, then compute the gradient, update the parameter, repeat until the convergence. How it works? First initialize the parameter in gradient descent. Then start with random values for parameters like your weights when we are talking about deep learning network. Then compute the gradient means calculate the gradient, means the partial derivative of the cost function with respect to each parameter. Then how will update the parameter? Just adjust the parameters by moving the direction of the negative gradient. Then repeat these steps, means stop when the parameter updates become very small or reach a predefined number of iterations. What is the formula for gradient descent? It's theta is equal to theta minus alpha of dz upon d theta. Theta is the parameter to be optimized, and alpha is the learning rate, that is step size. Dj upon d theta is equal to the gradient of the cost function, and there are some there's some types of gradient descent algorithm also. What is types? If we'll talk about, one type is stochastic gradient descent, batch gradient descent, and then another one, mini batch gradient descent. All those stuff comes to play. Okay, what is all those stuff? What is batch gradient descent? It uses an entire data set to compute the gradient, means it is stable but slow of the large low. It is stable but slow for large amount of data set. Batch gradient descent means convex function with small data set. When we are calculating, we are using batch gradient descent. What is stochastic gradient descent? That we are using commonly in machine learning or deep learning. SGD, stochastic gradient descent, uses a single random data point for iteration and faster, but it introduces the noise, means the fluctuations will be more in case of stochastic gradient descent. Okay, means the large data set where full batch computation is expensive, we are using stochastic gradient descent. Then what is mini batch gradient descent? We are uses a small random subset, mini batch of a data, means that will balances the speed and stability, means commonly used in deep learning tasks, the mini batch gradient descent. Got it? What are the various applications of gradient descent? We are using in machine learning, deep learning, some optimization problem, means your in machine learning it is optimizing the weights in linear regression, logistic regression, then some other regression type algorithm. In deep learning, it trains the neural networks using back propagation technique, gradient descent. Then optimization problems like portfolio management, supply chain optimization, like this, we are using gradient descent. Means it is the gradient descent is a fundamental optimization algorithm in machine learning that we are using for understanding how to tune the parameter like the learning rate, batch size. Those are important for model training. Yes.
Yes, sir.
Yes.
So what we have discussed, then we have going for gradient descent. Anyone can tell me? Can you tell me? भूल गया भाई. हम लोग क्या डिस्कस कर रहे थे?
Predictive analytics.
अरे नहीं, उसके बाद एक ऑप्टिमाइजेशन भाई.
Yes, sir.
Yeah, non-linear optimization, then integer optimization, non-linear optimization we have discussed. In non-linear optimization, it comes gradient. Then the third type of optimization is integer optimization, means the when decision variables must be integers, means deciding how many machines to buy. Then the techniques like cutting plane method, branch and bound, all are using for this integer optimization. Then the fourth one is dynamic optimization. What is dynamic optimization? We are using for this for multi-stage decision problems where choices affect the future state. Okay, means your inventory management system, all this are used. Then stochastic optimization that I've discussed with you. Then what are the various applications of optimization? We are using in businesses, finance, machine learning, healthcare, Then optimization algorithm in machine learning that I have told you, that gradient descent, that is theta is equal to theta minus alpha minus d upon, told you, right? What is gradient descent in the formula I told you?
Yes.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
So first, in what I discussing your, now it comes to the our topic, that is prescriptive analytics. Okay, means prescriptive analytics provides the recommendation for the best course of action based on predictive insights, and it uses optimization algorithm and AI to suggest the decision making strategies. What are the key techniques we are using for some optimization algorithm, like what dysentery and simulation modeling, AI driven recommendation system. Some common examples of optimization algorithms, like the descriptive analytics are personalized product recommendation, optimizing the supply chain logistic for cost efficiency, dynamic price modeling. This, okay, means each type of data analytics means either your descriptive, diagnostic, predictive, or prescriptive. It plays a crucial role in data driven decision making, and the organizations often combine this analytics technique to gain deeper insights and improve business performance. Okay, done. Okay, now so we'll discuss the machine learning, or will it comes to structured and unstructured data. Here it comes to machine learning. Okay, cool. Now, so what is machine learning? Who coined the term machine learning first? अरे सब लोग हो ना, तुम लोग मुझे बोल रहे हो डिस्कस करने के लिए, कर रहा हूँ.
Yes, sir.
Everyone is there ना?
Yes, sir.
Yes, sir.
Guys,
Yes.
you all are enjoying
Yes,
this
sir.
class. Means will be not going in the whole journey, will be not going only with the PPT. Okay, what are the things comes to our mind, what are the things comes in the way, we'll discuss. Okay, if I don't know something, if I'm going wrong direction, you can tell me, sir, please ignore this, we know this, we don't want to discuss this, anything that you can. Okay, be friendly, guys, don't be stressed that I'm the faculty over here, I'm the trainer over here, that I'll called you or anything. Don't think like that. Cool.
Yes, sir.
Yes, sir.
So now it comes to data sources. In data sources means data can be collected from various sources, including surveys, transactions, social media. And structured data is the data that is organized in a predefined manner, while unstructured data is more varied. And understanding the data sources of data is crucial and effective analysis for visualization. When it comes to structured and unstructured data, what is structured data? It can be displayed in rows, columns, and relational databases. In unstructured data, it cannot be displayed in rows, columns, and relational databases. What are the number of numbers, dates, and strings are available in that? Means in structured data, numbers, dates, and strings are available, but in unstructured data, the images, audio, video, word processing files, emails, spreadsheets is available. Then estimated 20% of enterprise data that structured data represents, then estimated 80% of the enterprise data in unstructured data. Then it requires less storage, but the unstructured data requires more storage, and it is easier to manage, protect with legacy solutions. But in unstructured data, it is more difficult to manage and protect with legacy solutions. In structured data means your table, columns, rows will be there. Then in unstructured data, the image data, text data, these are when it comes to unsupervised as well. So now come to the topic, that is machine learning. Arthur Samuel coined the term machine learning in 1959. What is machine learning if we'll talk about? It is the machine learning is the ability of a machine to learn from the data and replicate the human behavior. And it allows programs to learn automatically and make computers more intelligent without being explicitly programmed. Please mark the term, or you can note it down. Because when it comes to data analytics, machine learning, deep learning, data science, artificial intelligence, Tom should be in your tip of your tongue. Yeah? Should I repeat?
Yes, sir.
Yes.
Please one more time.
Arthur Samuel coined the term machine learning in 1951. And what is machine learning if we'll talk about? Machine learning is the ability of a machine to learn from the data and replicate the human behavior, and it allows programs to learn automatically and make computers more intelligent without being explicitly programmed. The recording will be shared along with all of you, so don't worry, don't be stressed. You can go there and listen to it. Okay.
Okay, sir.
Sir,
Yes, sir.
sir, what's the difference between data analysis and data analytics, sir? I'm a bit confused between these two.
Listen. Analytics involves analysis.
Okay, okay, sir.
मीन्स एनालिटिक्स में एनालिसिस ही होते हैं. ठीक है.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Cool.
Hello, sir.
हाँ हेलो.
Sir, string would be one string.
क्या बात?
String का meaning क्या होता है?
What?
Numbers, data, and strings. Structured data में second line. Number, dates, and strings. What is meaning of strings?
Means you are talking about string. Means
In
what?
the structured data.
Means string.
Yes.
अरे भाई. अरे string means what? It's simple. Means is a what? Sequence of character used to represent the text. It is called string. That can include letters, numbers, symbols, and white space as well. str you are talking about, right?
Yes.
String in Python. That
Yes.
represented by str. In Java, it's represented by string. In C++, it's represented by std string. Then in JavaScript, string. Then in SQL, we are representing the string using varchar and text. Okay. Yes.
Yes, sir. Okay.
Okay. Okay, guys. If anything comes to play, you can ask me. Okay, I'll be happy to answer that. Look. Cool. Okay. So we're discussing machine learning. So there are three types of machine learning. Okay. What are those?
Supervised, unsupervised reinforcement.
What is supervised?
Supervised means, for example, if the input and output are mentioned in a label,
Mm-hmm.
and unsupervised means if they are not labeled, the machine learning will be just identifying using the patterns and all.
Uh-huh. Okay, let me discuss. Everyone, please listen to me carefully. Supervised means when the algorithm uses a data developed by supervised environment or uses a labeled data, that is structured data. Here it comes structured data, that is supervised. When it comes to unsupervised learning, it is all about unstructured data, means no, unlabeled data. Supervised labeled data, unsupervised unlabeled. Okay, if I'll talk about supervised in details, when the model is trained on labeled dataset, means that each training example is associated with a correct output. Means it is used for classification and revision based program. Okay. Some of the common examples of supervised learning like spam detection, loan approval, stock price predictions, some algorithms related to linear regression, logistic regression, decision trees, support vector machines, neural networks. This comes under supervised. Then it comes to unsupervised learning. Unsupervised means unlabeled data set, means no supervised is required. Means so when model finds the pattern, structures, or relationships in data without predefined labels. I mean your text data, image data, these are unsupervised data. And this used clustering and association rule and dimensionality reduction. There are three types. I discuss it further. Okay, some of the common examples of unsupervised learning when we're talking about like customer segmentation, anomaly detection, market basket analysis, all things comes into picture. Some of the common algorithms like k-means clustering, hierarchical clustering, PCA, principal component analysis, autoencoders. Then it comes to reinforcement algorithm. Okay, Some reinforcement algorithm will discuss further. Okay. First, we'll discuss the supervised. Okay. Just a second, guys. Okay. Okay. So supervised is classified first into two types. One is classification, another one is regression. What is classification? What is regression? Who can tell me what is classification and what is regression? Anyone?
Sir, classification means the process of predicting discrete output values from the input. For example, whether a student will pass or fail.
Then
Sir,
what?
regression, I would say it's a form of supervised learning where the outcome comes into a numeric value. The level which is predicted by the model comes to a numeric value, and the classification is when the label represents a category or a class.
Classification means when you segregate the data into two or more categories with one or more input. Means the model predicts the value of one or more outcome. What is
Yeah,
regression in that case? Regression it try to establish the relationship between input and output variables, and it is used mainly for forecasts or predict the value of stock market, something like that. Means what is regression? When the dependent value changes according to the independent variable, that is called regression. Okay.
okay.
These are the two types when you are using it for supervised learning. Okay.
But sir, I wanted to ask, like regression mostly it gives to a numeric output, right? Like obviously there is a numerical value at the end, like the predicting the stocks, or like it will always result into a numeric value. Yeah, yeah. Okay, sir.
So everyone understood what is regression, what is classification?
Yes, sir.
Right. Actually, due to class, I have the class from 5 p.m. That's why I'm not in an energized mode. Okay. As I'm explaining in a flow, so listen to me carefully now. Yes. Don't interfere. We have discussed that supervised is two types. That is classification and another one is regression. What is classification? What is regression? You know. Then, what is on before going to unsupervised? Let me discuss the ML pipeline. What is the machine learning pipeline? It is cyclical and iterative. First step is data collection, data preparation, then feature extraction. Then it comes to model building, model training, test the model, then predictions. Then if the prediction is not up to that point, then back provided to the network, then change your features. Feature engineer, feature extraction techniques will be performed separate. Again, one second. Then, what are the Python packages used in machine learning? The Python is what? It is a high-level programming language that helps programmers to write a code that is clear, organized, and logical. And we are using some Python libraries like NumPy, Pandas, TensorFlow, Matplotlib, Scikit, Scikit-learn, Keras, PyTorch. For these are some of the libraries, right? Then, when it comes to supervised learning, that we were told, machine trained with labeled data as input, then linear, less segregation, multi-class classification, decision tree, support vector machine, this comes under supervised learning. Classification regression, done. Then it comes to how you prepare and shape your data. It's important for data analytics also. So listen to me carefully, very carefully. Yes.
Yes, sir.
So when it comes to preparing and stepping data, so when you are performing the EDS job, like your what uh, exploratory data analytics. Okay. Yes, guys, am I audible?
Yes, sir.
Yes, sir.
When you are using exploratory data analytics in uh, uh, it may be your data science, machine learning, or anything. Okay, in that we are using EDA technique to prepare and save the data. Means it, the things that are important for means analysis and all. Okay, that's why you are using. Guys, are you all are there or not? If you are not there, I'm not interested to discuss.
Sir, can't hear you. The last part you said.
What? Can't hear the last part I told you.
Yeah, yeah, yeah.
Okay. Means when it comes to preparing and stepping the data, it is done by using, you can done it, or you can do it by using your uh, Jupyter notebook or Google Color or something like that. Means EDA task you have to perform. EDA means exploratory data analysis. It means you have to understand your data, that so that you can select your feature accordingly. Okay, because feature selection plays a vital role in case of machine learning models when you're creating for better accuracy, not to face the overfitting problem like this. Okay, so to what is overfitting, what is underfitting, you got it? What is overfitting and what is underfitting, anyone?
So
What is
overfitting is basically the data learns more about the machine learning learns more about the data set,
uh-huh.
and underfitting is we give less information to the machine learning about the data set. Is
Means when the model is too simple, that is called underfitting. The too complex for the test data, it is called overfitting. Okay, so there to overcome the overfitting, there is a term we are using for regularization. What is regularization? Regularization forms the regression that swings the coefficient towards zero. Am I audible to all, or should I be
Yes, sir.
little?
Yes,
Am
yes,
I
we are
audible?
listening to you.
Yes.
Guys, please excuse me because my voice I cannot be louder now because energy level is very low. So regularization means it forms the regression that shrinks the coefficient towards zero. Means it is the difference. There is a term called RSS. That is the difference between actual and predicted. There are some types of regularization techniques like dropout, early stopping, co-adaptation, lasso regression, and ridge regression. Lasso is L1 regularization, and then ridge regression is a L2 regularization. What is dropout? First, understand the term, the regulation term. What is dropout? Dropout is the means the more units you dropped out, the stronger is the regularization. What is the early stopping? We use large number of epochs and plot to plot the validation loss graph. What is co-adaptation? When neurons, it comes under deep learning. When neurons predict the patterns in the training data using output of specific neurons. What is lasso regression and ridge regression? There is a difference between lasso regression and ridge regression. That is L1 regulation and L2 regulation. L1 regulation means your lasso penalizes the weights in proportion to the sum of the absolute values in the weights, and ridge regression that shrinks the coefficients close to zero for unimportant predictors, but never make them exactly zero. Means the difference between ridge regression and lasso regression is ridge regression shrinks the coefficient towards zero to reduce the complexity of the data. But lasso regression makes some of the coefficient estimate to be exactly equal to zero. Ridge regression shrinks the coefficient towards zero, but never make them exactly zero. But lasso do, it uh, shrinks the coefficient estimates to be exactly equal to zero. Got it? The difference
So,
between, yeah, yeah. Thank you. So there are some techniques like when you're talking about supervised learning, linear regression, multiple linear regression, decision tree, polynomial, support vector machines. Okay, what are all those algorithms? What is linear regression? Linear regression is popular modeling technique that predicts a continuous dependent variable based on the independent. And polynomial is a part of linear regression only when dependent variable is constant and independent variable may be means independent variable is constant and dependent variable can be changed. Yes.
Yes, sir.
Yeah. So how we'll work with linear regression is some of the example like variance inflation factor, that is VIF, we are using for linear regression. Then linear regression using Boston dataset, commonly we are using this. Then what is logistic regression? Logistic regression is used to predict a data value based on the prior observations of a data set, and is a machine learning used in classification problem. there there a term comes, that is sigmoid function. Sigmoid function is what? There is a term called sigmoid function, ReLU functions in deep learning, rectified linear unit. When it comes to CNN, fully connected layer, before fully connected layer, before pooling layer, there is a layer called ReLU, rectified linear unit layer. Okay, means f of x is equal to 0, 1, means f of x is equal to 0 when x is greater than equal less than equal to 0, and it's f of x is equal to x or 1 when f of x is greater than equal to 0. Okay, there's a formula for LU, and there is a formula for sigmoid function also. Sigmoid function is f of x is equal to 1 upon 1 plus e to the power minus x. Means just bouncing, right? No one can understand. अरे भाई किसी को समझ नहीं आ रहा है कुछ?
Yes sir, I can understand.
अरे भाई कोई तो है, और लोग और कोई है जिसको समझ में आ रहा है?
Yes sir, I can understand.
समझ में आ रहा है ना? समझ में आ रहा है ना?
Yes, sir.
Payal,
Yes.
Yes sir.
those, please raise your hand, those you can understand the terms. Else I can go in a bit detail. Raise your hand, guys. I can see the chat. देखना चाहता हूँ कौन कौन समझ रहा है, कौन कौन बस सुन रहा है. अगर सुनोगे so be with a pen and paper so that you can note it down. अरे भाई, अरे सब लोग समझ रहे हो क्या? मतलब मैं फालतू में शक कर रहा हूँ तुम लोगों को. अनुराग, are you there? Anurag,
Yes, sir.
then Sarvesh, Srirang, Santosh,
Yes, sir. Yes.
Pooja,
Yes, sir.
Saiteja,
Yes,
Shivangi,
sir.
Payal. अरे भाई साहब, अरे 50 लोग हाथ खड़े किए, मैं क्या नहीं मतलब ठीक है भाई, मतलब मैं गधा हूँ शायद, मैं गधा हूँ जो मैं तुम लोगों को गधा समझ रहा हूँ. ठीक है, तो तुम लोग बहुत इंटेलिजेंट हो भाई. थैंक यू. सो you can understand the term sigmoid function, right?
Yes, sir.
ठीक.
Yes.
Thank you. So happy. So sigmoid function is f of x is equal to 1 upon 1 plus e to the minus x. So it's all about, there are some terms. If you want to discuss some of the machine learning algorithms, how the algorithm works, how the clustering, association, the instant reduction. If you want to discuss, so let me tell you what are the class. Okay, you can raise, all of you lower your hand. So in the meantime, I just want to tell you that we'll discuss SQL in 2 more classes. Okay, database with SQL, some advanced topics like functional dependencies, normalizations, transaction history, that is ACID property, natural joining, then linear algebra, some intersection, union operation, intersection operation, then some enuncier modeling, serialization, schedulers, all of those we'll discuss. The advanced topics of including, we'll start with the basics also. Just overview of the basics, then we'll in detail we'll discuss the advanced topics of databases. Then some machine learning algorithms if we'll tell, then we'll discuss as well. Don't worry about that. Okay, we'll discuss over time to time what are the stops comes into picture. We'll discuss. Okay, some predictive analytics stops, some NLP stops. That is whatever is required for data analytics as well. Okay, cool.
Yes.
Yes, sir.
Yes, sir.
Yes.
So now next in machine learning, some supervisor. What is polynomial regression? Polynomial regression, it provides the relationship between dependent and independent variables. Means works when it is a part of linear regression, right? Means it works when data points are not captured by the linear regression model. Means where the line is non-linear and not able to find the data set, there we are using polynomial regression. There is a term called multiple linear regression. Where, okay, Pooja, Vishal, all of you, please means lower your hand. You may lower your hand. Okay. So, what is multiple linear regression? When what? When the dependent value. So, what is the difference between simple linear and multiple linear? Who can tell me? If you are understanding the terms, what is the difference between simple linear and multiple linear? In simple linear, there is one single independent variable and one single dependent variable. But in multiple linear regression, multiple independent variable, but one single dependent variable will be there. The equation will be like this: your for simple linear regression, for simple linear regression, the equation is y is equal to mx plus c. Yes.
Yes, sir.
Yeah,
Yes, sir.
y is dependent, x is independent, and m is the intercept, and c is constant. Yes.
Yes, sir.
Yes.
समझ रहे हैं, कोई नहीं समझ रहा, मुझे कुछ समझ नहीं आ रहा. ठीक है, thank you. So in multiple linear regression, the equation will be like y is equal to mx plus mx1 plus m2x2 plus m2x3 plus c1 c2 c3, something like that. Okay. Then when it
Yes,
comes
sir.
to Ries regression, lapse regression, we discuss. Then there is a term in machine learning that is Cohen's kappa. Cohen's kappa. Anyone heard the term Cohen's kappa? Cohen's kappa is used to compare the predictions done by the machine learning model. We are using Cohen's kappa for. Okay. Can you? Okay. Okay. Sure. I'll be slow down. Okay. Cohen's kappa means to compare the predictions done by the machine learning model. We use the Cohen's kappa. The equation for Cohen's kappa is K is equal to P0 minus PE upon 1 minus PE. What is P0? It is the accuracy of the model. What is PE? It is used to measure the agreement between the model predictions and actual classes. Okay, got it? What is Cohen's kappa? Guys, don't worry. We'll discuss over time. Don't worry about anything. Okay, we're discussing the machine learning, right? When it comes to, if you'll tell me to discuss what are the machine learning, the algorithms, if you'll tell me to discuss, then definitely I'll go for that. Whatever comes to your mind, just tell me. And the maximum both comes into picture. Okay. Well, then it's all gone for supervised learning. Then it comes to unsupervised learning. It is of three types. Unsupervised. What are the three types of unsupervised learning? Clustering, association, then dimensional reduction. What is clustering? Clustering means it divides the set of data points into multiple clusters. Means it aims to segregate the data points with similar traits or similar characteristics. Then what is association? We find the relationship between the variables in large data set. Association I'm talking about. Means it determines the dependencies of one data item over another data item. Means you can find its application in market basket analysis also. What is dimensional reduction? Dimensional reduction, one common example is principal component analysis, singular variety composition, all those stuff. What is principal component analysis and how dimensional reduction is actually works? I've dimensional. Sir, can you provide the notes of the PPT possible to build in this different region? Guys, notes or PPT means I'll provide. I'm discussing by my own. So you can note it down. Okay, you can search it in Google. I don't have the if my engineering and my master's note I can collect and I can send you, but let's see. Guys, you are understanding, na? Then you can note it down. What are the
See, we are getting your point. We are getting what you are describing, but some, some words are like different pronounced in north region and south region. So that's the barrier here, I guess, for me especially. I don't know about everyone.
You are correct.
means what is the issue you are facing? Can you tell
Like
me?
my name is Anurag. Anurag is pronounced in different region from different types. Like Anurag is Anurag here, but when we go to south, it may be Anurag or something different pronoun.
So
I'm
what's the
mistaken.
problem with English?
We are getting your description, but we are not getting your particular words that you are pronouncing. Like we are getting regression, but after regression, like if something, we are not getting that. Like you're getting my point.
Man, means I'm a bit faster. You're talking about
No,
I'll be
you
slow.
are not faster. Just your pronunciation is bit different from us.
Okay, means north and south. You are from south region.
No, I'm from north.
Okay, north region.
Yeah, I'm from Noida.
Okay, what can I do for that?
If possible, if notes are possible, you can provide us that just for better understanding of
Or
topics.
else you can provide this PPT which you are sharing right now on your
No,
screen.
PPT though also
Yeah.
definitely I'll share the PPT. Don't worry about that.
Yeah.
Okay, let me discuss first. Okay, I can
Okay.
beat slower also if you'll tell me. So there unsupervised is classified into three types. One is clustering, association, then dimensionality reduction. What is clustering? Clustering means you divide the set of data points into multiple cluster. Means it aims to segregate the data points with similar traits or similar characteristics. Association means it finds the relationship between variables in large set of data set. Means it will determine the dependencies of one data item over another data item. Means we can find its application in market basket analysis, some dimensional reduction techniques like PCA that identifies the patterns in data set and simplifies the data set by reducing the dimensionality of the data. That's why we're using dimensional reduction. Then there is a term. Then further classification can be done by using, there are various types of clustering types are also available. So clustering types, like there are four types of clustering: centroid based clustering, density based clustering, distribution based clustering, and hierarchical clustering. Okay, what is centroid based, density based, distribution clustering, hierarchical clustering? So let me discuss first one, that is centroid based clustering. That is your k-means clustering works under that. Means it is unsupervised machine learning algorithm that groups the unlabeled data into cluster by identifying k number of centroid. Means it is centroid, means what? Centroid based algorithm that groups the unlabeled data into k number of cluster, each with a centroid, and it requires the number of cluster to be predefined. Yes. So in the next class itself, I'll try to explain all those topics in machine learning, and in the upcoming classes these are the basic things that that's why, means, if you'll tell me that I can prepare a note in my handwritten or in word or file like that, but these are the basic things. That's why I have not prepared the PPT for that. Yes. Also
Okay.
comes under data analytics, so you have to understand machine learning. So, guys, is the class is informative? Tableau is covering the intern. Yes, sir. Tableau tool is covering this internship. We'll discuss the Power BI. Okay.
Sir, can you provide the PPT that you showed?
This PPT कुछ मतलब अभी तक तो कुछ डिस्कस भी नहीं किए हम लोग, but I'll share. Okay. But tomorrow or day after tomorrow, you will have another class. There we will complete this PPT, and this is the first one PPT. Okay, and the others, when time comes, then what are the things we will discuss? Okay, let me tell you first. In data analytics, what are the things we are going to discuss? Some EDA techniques we will discuss, then Power BI will discuss, then uh, some of the techniques, how to dealing with different types of data, what are the types of data, then data visualization for decision making, then data science for data analytics, machine learning in data analytics, what is the use of machine learning, then data analytics in different sectors, then some of the frameworks and latest trends in data analytics. All those stuff we'll discuss time to time. Okay, as this is the introduction class, this is the starting of the internship program. I have discussed the, means overally I am discussing. Okay, getting it?
Yes, sir.
Okay.
Yes, sir.
So is the class is informative? You enjoyed the class, or I'll be, means I can try to bit slower. Cool.
Yes, sir. We enjoyed it, sir.
Yeah. So thank you all. Let's meet in the next class. Okay. Have a good night.
Good night, sir.
Thank you, sir. Good night, sir. Good night, sir.
Good night.
Thank you. Good night.